This is one of the many, actually. It's been getting a lot of seminars in the HDR UK seminar series in applied analytics. And Kacper Sokol is going to give us a talk just now on your way to Melbourne to work on explainable analytics, explainable machine learning, I suppose. Take it away, Kacper.
Thanks so much, Dave. Right. First, early sharing the screen. Great. I'll switch between these slides and a few interactive examples just to demonstrate what I'm talking about throughout the way. So I'm Kacper. Hello, everybody. I'm a researcher at the University of Bristol. And in this talk, I'll try to convince you that some of our research tools may be out of date. And what's the way forward, using the example of how to better manage the publication lifecycle, especially with some interactive outputs such as presentations, documents, etc. So in short, this will be how to build research tools that can give you outputs that are interactive, approachable, reproducible, and most importantly, for you, the authors, easier to write and organize. A bit about my background. So I did my PhD in computer science, in particular, explainable artificial intelligence and interpretable machine learning. But I also did some work on research software engineering and teaching. And as I was doing my research on explainable AI, I could get these results, which were really nice, in a black box, so a predictive model that nobody really knows how it works, and then present the explanations of that model to some audience. And I myself, I'm a computer scientist, I could dig around, I could see how it behaves. But when it came to presenting these research outputs to a more broader audience, it was a bit tricky, because usually I had to use slides in PDF or PowerPoint, so just static images, and it wasn't really working for me. So I was looking for something better, something that would convey the message to the audience and not just show them pretty pictures. Fortunately, a project came about called Tailor, and it's about foundations of trustworthy AI by integrating reasoning, learning, and optimization. And I am working for that project at the moment at the University of Bristol. And as you can see, it has quite important scientific program, but there is also another aspect to this consortium, research consortium, which consists of more than 40 partners across Europe. And this is how to coordinate research, how to collaborate, how to disseminate research findings, and all of the facilitation that goes around that. So how to really do research, and are we doing it in the best possible way that we can? So one of the themes in this aspect of Tailor is rethinking how academics work, and in particular looking for new ways of working. And if you've done some reviewing, for example, you may have come across EasyChair or other tools that help us to do review, submission, conference management. And there is a lot to be wished for in case of tools like that, because if you, for example, compare it to commercial software engineering, software development platforms such as GitHub or Bitbucket, these are miles away. These are two different worlds. So one thing that is more from the computer science perspective is how to improve these tools purely based on usability and functionality. But then also, even my background in AI and machine learning, can we actually use this sort of predictive algorithms to improve how we work? And I'll give you a few examples, and one of them is recommendations. So in academia, we have people and we have a lot of text. So can we match people to text and people to people? Yes, we can. And you can use a very, very simple process to do that. And I will discuss use cases in a moment. And it is as simple as basically getting data about people. So for example, their publications, it's enough to get titles of their publications, then extract these keywords, compute similarity between keywords for different people, and then you can match people together. You could also possibly match people to text. So for example, get a bunch of text, get keywords for a given person, and see whether a person matches to a particular piece of text. And how can we use that to improve academic workflow where, well, we can do matching of scientific papers with reviewers. And this is what my research group has done before. So for example, when you go for reviewing papers, you may have to scroll through pages and pages of submissions for review, and then you vote on them. It takes quite a lot of time, and we can make this process a bit less painful by giving recommendations or suggestions to people what they may be interested in reviewing. Another aspect of matching and recommendations is matching people to people. So within Taylor, we have this 40 or so partners. And when we meet, we sometimes do breakout groups via Zoom, for example. And one way to do that is to just randomly assign people to breakout rooms. But can we do better? And can we, for example, match people based on their interests? If we know who's attending upfront, we could possibly match people and then make these discussions more interesting, more engaging. You could also, for example, match internal partners to external partners, for example, looking for collaborations or just browsing through research outputs of somebody, in a more creative way than just scrolling through the list of publications. So the previous one, the recommendation bit, is the work that we actually did and we tried it out. This is more conceptual. So coming back to the review process, what usually happens is you get a PDF of a paper and you are asked to review it. You probably have some way to make notes. Hopefully the PDF has line numbers and page numbers so that you can refer. Sometimes you may need to copy a piece of text from the PDF, the paper that you're reviewing. And if any of you have tried it, this is usually really painful, trying to get a block of text from a PDF, copy paste it, especially when there are numbers overlaid on top of the paper itself. And then you use your notes to possibly fill in a review form. And then you may need to get back to the PDF to check whether you're referring to the right line numbers or text excerpts, etc. So you kind of have to go out here and use some, have your own workflow to review papers. In comparison, if you've ever done any software engineering, you may have come across software review process, for example, at GitHub, where you can comment on particular lines of code. You can have a discussion. You can create checklists for people to resolve tasks. You can create automatic checks whether everything compiles, whether tests pass, etc. So it's way more supportive when it comes to reviewing software. And if you compare that with how we review papers, again, I think we're lacking some fundamental tools to do our work right. And there are some examples of academics trying to resolve these problems. And one which some of you may be familiar with is Open Review, where you have a paper and you can actually discuss and comment on the paper and submit your reviews. But it still doesn't provide anything beyond this framework for discussion and publishing your comments. Another great example, and I think this is very interesting, is how the open journals handle paper reviews. So one of the open journals is the Journal of Open Source Software. And these are basically very short papers introducing new software packages. And the way they handle reviews is via GitHub issues. So what happens is when you submit your paper, a GitHub issue is open and then everything happens there. So you have full provenance of when the paper was submitted, what revisions were done to the paper. People who reviewed leave their comments there. You get reviewer checkboxes to check everything. So it's a bit more organized, and GitHub in a way facilitates the review process. But review is just one aspect of publishing. Then we also have to write the paper itself. And if you think about it, it's quite surprising because from the very early on, when text was hand-copied, handwritten, all the way through printing presses and typewriters, and now with PDFs, there's not much difference in what goes into these output formats. So it may be easier to copy, edit, send around, and preserve text, but we are still pretty much limited to what it was originally. Some images and some text, and that's probably just it. To be fair, there were attempts to go beyond pure static text, and you may have heard of distill.pub. Unfortunately, it has ceased publications recently, but if you have a look at their articles, they're really engaging. You have interactive visualizations. You can play around with the content that they are explaining in these articles. However, just to write an article like that, you would have to be familiar with plenty of web technologies, and you can't really expect every single researcher to know how to do interactive visualizations on the web. So again, can we somehow get such results without learning all of the web technologies that are usually required to create content like this? And again, if you think about presentations, we end up with the same story. It may have been just chalkboard and some drawings at first, then maybe transparencies and projecting that. And now we are with PowerPoint, which is pretty much the same, maybe a bit more efficient, easier to build, easier to create, but it inherits the same limiting factors. You may be able to embed a video or something else, but in the end, most of the presentations are static. And there are two perspectives that you can have on this sort of academic publishing. One is based on the output, so what you are producing, in which case you view every single research outcome, research output as a standalone entity. So for example, papers, presentations, posters. More recently, this is expanding. So we also have code databases, computational notebooks, videos, press releases, blog posts, etc. But then we treat them independently. We also can have another point of view, which I think is a bit more reasonable when it comes to whatever comes out of research. And these are what sort of input goes in to produce these outputs. And if you think about it, they all share the same things like text, figures, code, snippets. Again, some computational notebooks, maybe a video or an animation. But then again, even though the input may be the same, you may need to format it differently to get to the outputs that you desire, like slides or documents, web pages, computational notebooks, etc. So can we somehow merge these two viewpoints and go beyond that? Especially that it's not just that it's a lot of work, it actually can cause a lot of troubles. So if you view it as individual outputs, then say that you start with a paper and your paper gets published, great. Now you have to prepare slides. So you start copy pasting pieces of text from your document, maybe some figures. And what if you find typo? Then you have to go back to every single copy that you've made and fix it. Or what if you need to generate new figures? Again, you need to generate your figures somehow with your independent script and then copy paste these figures into your slides, into your paper. And then comes the issue of maintaining these multiple versions, which may be out of sync. And if you think about publishing paper itself, it may have gone through various steps in its lifetime, like for example, being first a note or a blog post, then evolving into a workshop paper, maybe then a conference paper, and finally a journal paper. Even though you probably reuse a lot of components, they become sort of separated and independent, and you have to manage all of these complexities that go with it. And finally, whatever you generate with these different sources usually ends up being a static PDF document, which I think it's quite a shame, especially these days when we are all meeting online and we can use these technologies to better communicate and better convey the message, whether it's to the general audience or fellow researchers. So even with tools that are available right now, they're usually pretty standalone, not really integrated. Maybe somebody did something, but they are not built into somehow overarching publication process. And by publication process, I mean composition of these outputs like text, figures, presentations, videos, what you may have. Then review, possibly revision and rebuttal if it's a scientific publication. And then finally putting it out there for people to read or to somehow interact with it. And because it's such a messy space, it usually translates into the lowest common denominator. So you have to use a PDF because it is widely accepted and works everywhere. And I think we can change that, and we can go beyond that. And this, I'll give you a moment to have a look at this cartoon, but it pretty much covers my experience with publishing tools. Yeah, so even though this may be the case, I think it's still worth pursuing better academic tools. So this is what we proposed in one of our papers, that instead of having all of these individual copies of your content, you have single repository with your text, figures, code, and then you generate different outputs that may be different versions of the same content. So you would have your text, your figures, your tables, all stored in a single place, and then somehow you generate whatever may be needed: a long presentation, a short paper, a long paper, blog post. It is quite difficult to achieve that with just one man working on it, but with the use of some open source tools and putting things together, I did manage to get something that is quite nice. It's not there yet, but I think it's a good start. And looking beyond that, what would be ideal is having separate repositories for these different building blocks that go into outputs. So you would have a separate repository of text that you could get source from, and same for figures, code. An interesting aspect of that is that figures may actually be code, because you usually produce figures, at least you often produce figures from code. So you have some code, some data, and you generate figures. So instead of storing them as static images, you may as well then the line blurs a bit, but you may store your figures as code and then just generate it based on different data. And just to give you one more reason why I'm doing it, recently I was giving a talk at the Alan Turing's AI UK conference. And originally it was planned as a half-a-day demo, I believe. So me and my colleague would go there and we would talk people through our research. We had some interactive tools that they could play with. But then it got, first of all, I had to do it online. And second of all, it got cut to, I believe, 10 or 15 minutes. And the obvious way out of it would be just to give a talk, like a set of slides. But it was a demo, and I wanted to preserve this aspect of my presentation. So I spent quite a bit of time just looking for suitable technologies and browsing around, and I finally got this thing that allows you to do interactive slides. And after my talk, I got a bunch of questions, but believe it or not, the top rated one was, what technology are you using for the slides? So I think people probably missed out on all of the content because they were so amazed by the technology underlying the slides. And I'll show you the same technology in a moment. So ending the boring part of the talk and going for the more demo-based part, I'll show you a few technologies and also how they come together to somehow make a step towards the goal of maintaining a single source of your research outputs and of your research outcomes, and then generating different output formats, different artifacts with that. And I'll show you, for example, Reveal.JS, which is a web-based framework for building just building online slides, Jupyter Notebooks, which you may be familiar with, and then launching them through Colab and MyBinder, as well as building some widgets for them. Then I'll show you Rise, which is a plugin for Jupyter Notebook that allows you to create interactive slides based on Reveal.JS with widgets and what have you. And then finally, Jupyter Book, which is a framework for building online articles. Then all of this comes together within a process which I call You Only Write Thrice. So this is basically a first step towards maintaining a single source and generating all of these different outputs based on these technologies. So let's start with Reveal.JS. And here, like I said, it's a web framework for building slides. You can write your slides either in HTML or Markdown. But then you have different ways of managing this content. So you can either have pure Markdown source, or you could possibly write your slides in Jupyter Notebook. And I will show you how these two different things work. So for the Reveal.js slides, if you write them in Markdown, it pretty much looks like that. So this is a simple Markdown file with one addition. And these are the triple plus separators between different parts of text. And if you look closely, you will see that this defines a slideshow and the slide type. And what it does here is basically separate the content into different sections and then prescribes how this piece of content between two plus sign lines should behave in this particular case when it is rendered as a slideshow. You can see all different tags there as well, but let's focus for now on slideshow. This may be a bit difficult to read and write, so there is a possibility to do the same annotation directly in a Jupyter Notebook. So if we have a look at this Jupyter Notebook, you will see that to the right of each cell, whether it's code or text, there is a slide type. So here you can indicate how this particular piece of content should behave. And once you do that, it allows you to generate a HTML with your slides. And this is an example of Reveal.js slides. So it's all online. You may embed some static HTML. So this is an embed of another web page. And this particular one is a distill.pub article. You have a 2D structure for your Reveal.js slides. So you can see that the slides go horizontally and vertically, which allows you to better manage the structure of your slides. Right. Let's have a look at another component, Jupyter Notebooks. So this allows you to write computational narrative, which is a bunch of Markdown for writing text and then some Python code or other programming language supported by Jupyter ecosystem. And then you can describe what you're doing. It's very similar to literate programming. And the advantage of these notebooks that you can actually share them and you can easily reproduce scientific results. You can either publish them in view-only format, which you can do via GitHub or ND Viewer. And then you can just see the code, the source code and Markdown, but you can't really execute or play with the code. But you can also execute them. Well, obviously you can execute them on your own computer, but this would require you to install all of the dependencies and packages which may not be desirable. So there are online execution environments such as Google Colab and MyBinder that allow you to play with these notebooks and reproduce the results without actually having to install anything. It's directly in the browser. And this may be all known to you, but I think that there are two interesting aspects worth showing in case of Jupyter Notebooks. And I have one in Colab. And other than it being a normal Jupyter Notebook, you will see two different editions here. So one is specific to Google Colab, and you can see it here. This gives you an opportunity in Google Colab to create simple user interfaces. So the bit on the right is rendered purely based on annotations in source code. So you can see here that the datedir variable here is annotated as a parameter of type string. And this creates this panel to the right, which allows you to change some parameters of your code without actually having to do any source code editing. So you can see that once I start editing this one, the source code edits as well. And in addition to simple strings, you can have drop-down lists, as well as integer inputs, Boolean flags, and sliders. So this allows you to somehow make your computational notebook more approachable to a lay audience, because they don't really have to think about how to change the code. They can just play with the parameters in a simple user interface that you pretty much get for free with simple source code annotations, and then execute your code. Another interesting aspect of Jupyter Notebooks that you may not know are Jupyter Widgets. So this works both with Colab, MyBinder, or any other Jupyter Notebooks execution, because it's based on a plugin. And it allows you to create simple widgets like checkboxes, text input, etc., to interact with your code. So by using both of these, the native Colab user interface as well as Jupyter Widgets, you can actually make a Jupyter Notebook very easy to use for your audience. Right. This is the most interesting part, I believe. So this is building interactive slides. So you may have seen that with the Reveal.JS slides, there is some interactivity in the sense that you can embed videos or you can embed other web pages. But if you have outputs or some widgets that require computation, can you somehow present them in your Reveal slides? And the answer is yes. There is an extension to the Jupyter Notebook platform called Rise, and this allows you to use the slide annotations that you've seen before. So the drop downs in the top right of your notebook cells and Jupyter Widgets to build really interactive and really engaging slideshows. So let me show you an example of this. And I'll use the notebook that I already presented to you. So this is just a Jupyter notebook, which I have pre-executed before the talk. And it has a bunch of code that is just to set up things, but also some Markdown and figures. These figures were produced with Python. So these are not figures embedded with HTML or Markdown. These are outputs of Python code. So let's have a look. Again, you get a Reveal presentation with some code and its executed output. But interestingly, you can also embed widgets. And this one is executed. So let me just show you that as you speak to your audience about your research outputs, you can actually show it with different examples. So here, this is one of AI explainability method based online, and it has different parameters. And because of these parameters, the explanations are affected quite badly. And otherwise, I would have to use a bunch of static figures. Whereas here, I can actually ask the audience some questions and then set it up to present the answer. So I think it's really cool. Then I have also another example for tabular data where you have also some sliders and figures that come out as a result when you execute it. It's important to know that if executing each step requires a lot of computation, you may need to pre-compute and cache. And this is what I did here. So for tabular data, so this particular example, it is okay to execute as I go. Whereas for the other example, it is quite computationally heavy to execute each step. So I had to pre-execute it and then save it in a data frame and then just read from the data frame. So with this one, it's actually computation happening in the background. Whereas in the previous one, it was retrieving data from a data frame. Right, so the next component is Jupyter Book. So we've seen slides, we've seen computational notebooks, but what about online articles? This is possible as well. And then with Jupyter Book framework, you can generate online model-looking articles that you can host on GitHub. So you don't need any hosting or any extra resources. You can write your source in Markdown, in particular MIST flavor of Markdown, but it can also be in Jupyter Notebooks or any other notebook format, as long as you can write the parser for that particular notebook type. You can embed figures, you can embed Python code. You can also hide Python code, but embed the result of the computation for this Python code. It also supports some scientific typesetting, like LaTeX equations and BibTeX bibliography management. So there are features there that are, I would say, sufficient to use it on daily basis. Let me give you a quick demo of source and how it compiles before we move on to putting it all together. So for Jupyter Book, you can have a bunch of Markdown files, each one, for example, being a chapter or a section. And GitHub already does a great job in rendering this. There may be a few parts that GitHub can't really handle because of different syntax, like, for example, figure embedding. But you can preview it here. Then you can build all of that into an online article. So this is article based on the Markdown sources that I showed you. And as you can see, it's pretty nice looking. You can go through the sections. It links back to your GitHub repository, so you can suggest edits to these documents or open an issue. I'll come back to more functionality of Jupyter Book in a moment, because it is the main part of my framework for building multiple outputs from single source. Right, so the secret sauce to put it all together is the thing that I called you only write thrice. And this is basically a workflow that allows you to have all of your content, whether these are text files written in Markdown or Jupyter Notebooks, figures, all in a version control environment, and then build 3 different formats at the moment from this source. And these are Jupyter Book, so an online document, Reveal.JS slides, whether static, so pure Reveal.JS, or Rise-based Reveal.JS with interactive components, as well as computational notebooks that you can launch either with Colab and My Binder, or download and execute them directly on your own machine. The infrastructure is based on controlling all these sources independently, and then using GitHub Actions, which I'll show in a moment, to build the end output formats. So you don't really need to compile anything. Everything happens automatically. The interesting aspect here is that if you have a bunch of text and you want to generate different versions of that text. So for example, imagine you having a set of slides and then you may be presenting to a lay audience, so you want some parts of it, or you may be presenting to your students and then you want other parts. Maybe you have some extra materials there that you sometimes want to include or not. You can tag these pieces of content as you could have with different types of slides, and then generate different versions from the same sources, which I think is quite handy. This is still very much work in progress, but it is already possible. And then again, you have version control on top of everything. So you can track changes, edits, and who's done what. Like I said, Jupyter Book already has quite a bit of academic features, but you may come across a certain use case where there isn't the functionality that you need or you want. And actually, you can get around it by writing your own plugins. And I have written a few plugins, which I'll show you in a moment. And since Jupyter Book is based on Sphinx, which is Python documentation engine, there is already quite a bit of Sphinx plugins that you could possibly reuse. And for the examples that I did, some are purely for fun, others are to facilitate an online edition of a book about Prolog and logical programming, are terminal windows, which may be interactive, exercise solution boxes in case you want to set out some exercises to your students, as well as bespoke code blocks. So because Jupyter Book comes from the Jupyter ecosystem, you can write your code in any programming language that is supported by Jupyter, whether it's Python, R, or Julia, or whatever else. But if you come across a language that is not natively supported, you can actually go around in two ways. One is writing your own Jupyter kernel, but you can also abstract it away to an external server and have code boxes that send your code to this server. And I will show you this in a moment. So even if Jupyter Book does not support your particular use case, you can write a plugin for that. Then, because I want to embrace the entire publishing process, it's not just about writing. So what about reviewing? Well, if you host all of these sources on GitHub, then you can possibly reuse the procedures that the open journals use. So the example I showed you with the Journal of Open Source Software. And then you can have a public review. You can comment on individual lines in the document. You can have a discussion. You can have checkboxes. So it allows for a much more rich interaction with the article itself. It's also permanently attached to the document, which means there is a record of submissions and edits. And then this gives you quite a lot of flexibility, for example, when you're resubmitting the article, because in this case, submitting the article is just pointing to the right version. Once you're ready and you're publishing, again, you don't have to generate any specific document. You would tag the version of the document ready to release and possibly archive it in one way or another. For bibliometrics, you could possibly mint DOIs and even go a bit further and use Google Analytics like tracking systems, which would allow you to see who links to your article and in what way, and how your article is situated on the web. Which again, I think is quite useful, especially that there are a lot of non-published articles like blog posts, Medium posts that may refer to your article, and it's difficult to track this at times. And finally, when it comes to presenting, everything is online, so you don't really need to send around PDFs or everything. You get these 3 different formats, which are the online document, the slides, and computational notebooks. But then, because it's all on the web, you also get improved accessibility. So first of all, you don't need to know a lot about computer science to run these examples and reproduce them, but then also you can use assistive technologies to make this content more accessible. And in the end, because it's all web technologies, you can do whatever is possible within this scope. Right, so let me show you the example of you only write thrice. So again, you've already seen that. These are the sources. There is also some source for slides, which is again written for the slides, which is again written in Markdown with these annotations. Then you don't need to compile anything. As you edit stuff on GitHub, this all gets compiled automatically on new edits, and your slides and your document, all of these get built and deployed as a web page on GitHub pages. So everything happens behind the scenes. Then you get your article. And this is interesting because you can actually put all of the resources that have to do with your paper in one place. So here for this article, in addition to the paper itself, which got published both on Open Review an archive, there's also a Jupyter Book version, so the version that we are viewing right now. Because it was reviewed on Open Review, I also link here to the review that happened. I gave a presentation about this topic. So here I linked my static slides and my interactive slides, but also this has been recorded through Slides Live. So I can embed the slide lives here as well. And I also cut my piece out because here on Slides Live, it was published as an entire session of the conference. So I cut it out from this entire block and published it on YouTube and linked it here as well. Finally, I also presented a poster. So the poster is here for people to view, along with guidelines on how to cite the work, etc. The entire article is here as it has been published in the PDF, along with the references. So this is all of the academic writing that may be helpful for you. But also slides are published here. And because slides are written in Markdown, you can possibly publish slides in multiple different versions. So one would be the Reveal.JS static version, so without any interactive widgets. But you can also publish it as a one page with some hidden code that helps to facilitate widgets, some embeds, like another web page. This is the Distill article that I already showed you. Another thing. So there is a possibility to publish a slightly altered version of your slide as a simple page for the convenience of readers. Then coming back to the extensions that I've made, just to give you a feel of how it is to once you write a plugin to offer new content. This is an example of an interactive terminal that I adapted. So you get this really nice presentation of how to install Spacey and use it, but you don't really need to know any HTML to create such a terminal animation. So here is a syntax that is used to create this particular example. So you can see that you just indicate that it's a terminal window, and then some optional parameters like the delay of typing and line delay, and then specification of each line to appear in your terminal. Then I also mentioned interlinked exercise and solution boxes. So you create this again with a very similar syntax, where you just indicate that this is an exercise and then a solution. If you use the same tag, so the thing that you see after the indication of exercise and solution, these get linked. So then you can have hyperlinks between exercise and solutions, which means that you can collect all of your solutions on a separate page and then link them. So this is another extension that I wrote when we were creating our materials. Then I also told you about supporting non-standard programming languages. So this is a box with SWI Prolog, which is a logical programming language. And in order to embed a box like this in your content, it is as simple as indicating that you want a switch box and then going ahead with the content, the code that you want the box to contain. And everything else happens behind the scenes. So then you can execute this code box directly within your document, which helps students learn because they don't have to go back to their terminal window or the SWI interpreter and copy paste the commands. They can do it directly within the web page. And we did similar code boxes for Cpulint, which is probabilistic logical programming language. And again, you can have your interactive code boxes here. And we did the same with ProbLog, and these are slightly different code boxes, but they're pretty much based on the same idea, so that you can edit your code and execute it directly on the page. Right, so this builds upon a lot of open source tools, and the way that we adapted it to our use case was either writing these custom plugins to help us achieve our goal, or by putting it all together in the framework that I call You Only Write Thrice. So what we did, we either extended it or we somehow glued it all together in a way to alleviate many issues that you would face when authoring different content. I think that this supports the publishing lifecycle a lot better than what we have right now. And even though this particular demo, this workflow is based on GitHub, it helps us to achieve that goal. However, there are some restrictions purely because GitHub is a software sharing platform and not a publication platform. So, for example, you can't do single or double blind reviews with that. And we may need to develop a platform for publishing these sort of materials that is directly aimed at scientific publishing. And finally, when executing these online notebooks, we are using compute resources that are either given for free by Google in case of Colab, or in case of MyBinder, it's supported by a number of universities. And I think we would need to rethink the funding for compute resources when it comes to this sort of online execution environments, if this is to be taken seriously, this publishing platform. Just one more thing that I forgot to show you. So if you do have code embedded in on your page, so in case of slides, here there's some code embedded, then you can execute this page as a Jupyter notebook. So then you can launch it, in this case, just MyBinder. And this will get you an IPython notebook version of this page, which is more focused on the code rather than the content itself. Right, I think that pretty much sums it up. Thanks so much for listening, and I'm happy to take any questions.
Thank you, Kacper. That was brilliant. I guess Dave could not stay on, so I'll step in. I don't see any questions so far, so let me kick off. How easy it is for someone like myself to pick it up? I come from a data science background, but have only been working on Word. I have not even done anything on LaTeX or anything. If I stay in for a weekend, can I just master the whole thing that you've shown?
Yeah, well, I think you can get to a point where you can actually make it usable for yourself. So first of all, this is far easier than LaTeX because it's just Markdown. So you are not, there is very simple syntax for ordered lists, for bullet points, embedding figures. This is pretty straightforward. Then you can reuse the repository that I use for the demo there, and you can just copy that, populate it with your own content, and hopefully that should work out of the box, because the all magic that happens behind the scenes should carry on with your own copy of that repository. So as you edit the content, it should figure out as you upload new stuff and then update the web page itself, the slides. There are a few things that, well, are not smooth sailing, so to speak. But yeah, you know, in the end, this is just me at the moment working on it. And I think if we kind of can convince ourselves that the way we do research is not very efficient and get enough resources, I think this would be amazing. But if you are after just individual things from that workflow, it should be pretty straightforward once you start integrating them, because, you know, it's just ad hoc glued together such that it doesn't require too much user input. You may run into some troubles.
Mm-hmm. Yeah. I have a couple of other questions I can keep on going, but it's probably better if we open to the floor. So if people want to come in, so you can either just unmute and ask directly, or raise your hands, or if you want to put something on the chat. Tim.
Yeah, so this is all very nice. I suspect, you're trying to change the world of doing publishing. I've tried that a few times in the past. One of the problems of commenting is the sociological aspects that, we tried this with post-publication peer review on PubMed to create PubMed Commons a few years ago at NCBI. And the problem was people just didn't put comments in because they're just too afraid of being found out. If you do it identifiably, people are worried about knock-on effects of criticizing senior people. If you do it anonymously, well, they don't trust that they're not going to be re-identified. So there is a sociological problem in a lot of this, quite apart from the technological issues. And a completely different thing. I don't know if you're aware of what is being done with Open Safely, because of course I do stuff with trusted research environments. A lot of the trusted research environments are based on VDIs. So you log in and you can see the data and do some analysis. But Ben Goldacre's pushing for a much more restricted model where you do everything in GitHub, everything is tracked. You can't see the data, phenotype data. You can only run something that comes out of GitHub. And so you get the provenance completely, and you know who's looked at what. So his argument was, do we trust the Home Office, for example, to do some analysis on all patients' data? Probably we wouldn't trust them if they had a VDI, but through this model, we might trust them because you could check what algorithm they were going to run, and you'd have an evidence trail of exactly what they did run. So if they said, well, we just want to gather some statistics, you'd be able to show that that was what they gathered. And that kind of, you can link all that back in your way to the presentation model at the end of it to show transparency. So those are my couple of comments.
Yeah. Thanks so much. That's really interesting.
No else. So Kacper, building on what Tim said, how confident are you that maybe those changes you suggest might take off?
Well, I'm not confident at all, to be honest. I just think, it all depends on what you're trying to do. In my case, I actually really enjoyed it because, first of all, it allows me to connect a bit better with my audience. But then also, I found out so many things about my own research just by trying to do these visualizations and then interacting with them. Because if you think about it and you're doing your data analytics and you're just changing variables and then executing the code, you probably won't check as many different options as you would if you had a widget. So then you build a widget just for yourself, and then you reuse it for talks and presentations or in your notebooks. I think it's really convenient, and it helps at least me do better research just because I force myself to do these sort of widgets and interactive things.
Have you found bugs as a result?
Yeah, well, an entire part of my research is based on the bug that I found in somebody else's code. It's not a bug per se, it's just a design choice that is really bad. And once you start playing with, so with the bit that I showed you with different colors changing and then the bars changing, this is basically generating explanations. And in order to generate the explanation, you have to remove a piece of image, but because you can't redo that, you occlude it with a patch of a color. And it seems that changing the occlusion color is quite significant for generating the explanations, which means if you chose the wrong color, you can't really trust your explanation, which is really bad because it's supposed to explain your black box model.
Kacper, in the interest of time, I'll ask the final question that was posed by Rosemary. Thank you for the fantastic talk. I wonder if you could talk about how you envisage teams moving to new workflows. One challenge I have noticed is that it's easy to try out a new tool as an individual, but harder to make the shift in bigger groups.
Yep.
I suppose collaboration would be challenging, especially if people come from different backgrounds and some of them may not be as technologically able as others. But then, well, I think it's an interesting thing. To be honest, I haven't really had any contributions to this project, so it's mostly me. I don't really know how that would work. But in the end, I imagine, so right now it's pretty raw, right? You use different tools or you edit text files directly. But in the end, I suppose I would want to have something like an overleaf, if you work in LaTeX or Word interface, where you can just drop things like, so I think that this would be quite amazing. So for example, the platform itself knowing the context of what you're about to embed. So for example, say that you have a figure and you want to embed a figure and it's a JPEG. So you just drop it there and it's a figure. But somebody who is more on the technical side, he may have some code to generate the figure. So instead of actually generating the figure and uploading a static figure, so that if anything changes, that person would have to rerun the code, somehow using the code as the backend for the figure. So then if the other person comes in who doesn't really know much about coding and you expose these parameters, or you say, if you put your new data here, then it will generate the figure automatically. This takes away a lot of complexities and also allows you to have everything in one place. So you don't only operate on the final artifacts like static images, but you can actually have the code embedded in the document and use it somehow as a proxy for your figure, therefore enabling other people who may not know about all of this to play with your figures. So there is a lot to be done there, but like I said, I don't think we will move away from PDFs anytime soon.
A couple of years ago, there was a journal, was PRJ, or there was one journal definitely, that was trying to encourage people to embed the data and code so that readers could just click and see something on the image, or zoom and identify outliers. And as far as I know, it didn't really fly because most of us, researchers basically would not deposit code and data.
Yeah, exactly. And this is yet another problem with this sort of interactive research outputs, because in order to have these widgets, you first of all have to publish your data. And second of all, you have to publish your code. And then you import your code in order to do the visualizations or to do the widgets. So on one hand, it's great because it forces you to publish code and data. And it's not like you'll find an empty URL to a GitHub repository where somebody was supposed to upload code, but it never happened, because this forces you to do that. But then again, it may be a showstopper for some people who don't want to share their code or data. So it's a double-edged sword, I suppose.
If you want an example of that, the ENCODE master paper in 2012 came complete with a virtual machine which would regenerate any of the figures in the master publication. And I don't think it embedded all the data. I think it pointed to repositories.
Well, so it seems to be doable then.
It's just very hard. I mean, we only did it for one paper.
Yeah, and then I suppose another question is whose responsibility is it? Because as the researchers, we already have to do the research, we have to prepare the presentation, we have to deliver everything, and then somebody needs to clean up the code, publish the code, maintain the code, and the list goes on and on and on.
Kacper, good luck in changing academic publishing. It's definitely a noble aim, but yeah, it's definitely.
Well, that's an advantage of using virtual machines, because of course then you are fairly, as long as you use versioned data pointers to repositories, you expect them to persist. Virtual machines should continue to run.
Yeah, and coming back to changing the publishing world, I suppose even if it doesn't change, at least maybe some people will pick up bits and pieces and use them in their own work. And I think that's already for the better. If there is a tool that can help you, you're just not aware of it, even if you cut it out from the entire workflow, as long as it helps you, it's great.
Kacper, two things. So Dave McKay has commented that maybe the only people you need to convince are the funding councils, and I guess things will follow if you have convinced the funders. And there is a question by Mintu. Is it possible to host the documents in an ordinary server supporting standard JavaScript, HTML, CSS, etc.? Or the only way to host
so
through Binder like platform? I know standard R bookdown files are quite flexible.
No. So in the end, the web page is a static HTML page. You can host it anywhere. Then you can indicate a URL to your own execution platform. So if you want to host if you want it to be all internal, you can achieve that goal with your own server. It's all a matter of configuration.
Brilliant. With that, we're a bit of a time, but Kacper, many thanks for this amazing talk. I'll try to get my students to at least engage and try to understand this concept and see if they can at least contribute something. Thank you very much. Thanks, everyone.
Thanks so much for the opportunity.
When is the next seminar? Shall we?
Is on the 28th of October at 2 p.m. And we will have Heidi Siebold presenting something on the Turing Way, a community and handbook for reproducible, ethical, and collaborative data science. So I hope you'll join us too. Thank you very much, Kacper.
Thanks, everyone. Thanks, Kacper.
Thanks so much.
Thank you, Kacper.
Bye-bye.
Bye.